In this video, we're going to be looking at how to find the prime factors of numbers such as these over here. To find prime factors, you first want to be able to answer the question, what are prime numbers? Prime numbers are numbers that can only be divided by 1 and themselves. So the first 10 prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31. I lied. That is actually 11 numbers. So you can see if we look at a number like 11, can you divide 11 by any other number other than 11 or 1? Can you divide it evenly? So 2 doesn't divide 11 evenly, 3 doesn't divide 11 evenly, and so on. So 11 is a prime number because it only divides by 11 and 1. And same for all of these others. Now you might have a question, how do we know when a number is prime? And that is a very good question. For these smaller primes, it's pretty easy to check. You can just kind of do it in your head. Can I divide 23 by something other than 23 or 1? Does it divide by 2? No. Does it divide by 5? No. You can check that. When you get to larger numbers, it is much more difficult to know if it's prime. And in fact, that is a very important field of research for mathematicians to know when a number is prime. Prime numbers are a very important field of study. Okay, so we have this list of the smaller primes, and in fact, we won't have to go up to 31. We'll probably only need these 4 here, 2, 3, 5, and 7. And to find the prime factors of a number, you firstly want to start by dividing it by whichever number you think it will divide by evenly. So let's start with 36. What will 36 be divisible by? Well, I know from my times tables, 36 is 4 times 9. So you might want to start there. You might also realize that 36 is divisible by 3, so you could start at 3. I'm going to break it down into 4 and 9. Okay, so you want to find these factor pairs of the number. And you're creating a little factor tree here. And you're going to branch down until you get to the prime numbers. Now 4 is not a prime number, right? It's divisible by 1, 2, and 4. That's 3 factors. A prime number only has 2 factors. 9 is not a prime number. It's divisible by 1, 3, and 9. So we want to break 4 down again. 4 is 2 times 2. Okay, so hopefully you can see what I'm doing here. If we go up the tree again, 2 times 2 is 4. 4 times 9 is 36. So when we go down the tree, we're dividing into factors. When we go up the tree, we're multiplying. Okay, then 9 is 3 times 3. And now we have at the base of our tree here, all of these are prime numbers. So we are going to circle them. Okay, and what we've done is we've found the prime factors of 36. And a question might ask you, write 36 as the product of prime factors. And you would say it is 2 times 2 times 3 times 3. Okay. You might now ask, why do I want to do this? Another great question. Finding the prime factors of a number is really, really useful in a lot of cases. And one case we're going to look at in the next video is when we're looking for the highest common factor and lowest common multiple of a number, sometimes abbreviated as HCF and LCM. Okay, and when you're looking for these two things, it's really useful to be able to break a number down into its prime factors. Okay, let's have a look at 105. I want to break this number down into its prime factors. Again, start with the number you think 105 is going to be divisible by. Now, I know because it ends in 5, it's going to be divisible by 5. So I'm going to start with a factor pair of 5. And 5 times something must be 105. Well, 5 times 20 is 100. So 5 times 21 must be 105. And, you know, depending on the situation, you might be able to use a calculator for these. But sometimes these questions are also in non-calculator tests and things like that. So you need to be confident with doing that in your head as well. Okay, now actually I have a prime here already, right? 5 is in our list of primes. 5 is only divisible by itself and 1, but 21 is not a prime, so we need to keep branching down. What are the factors of 21? Thank you for times tables. That's 3 and 7, and these are prime numbers. Okay, so we have the prime factors of 105. Again, a typical question here is, it would look like this. Write, these numbers as a product of prime factors. So this is what the question would look like, and this is what you need to do. So 105, we can now say, is 3 times 5 times 7. And notice I order the numbers from lowest to highest. This is just a good practice to have. Okay, let's do 1500 now. Okay, 1500, we're going to break down into prime factors. Again, I'm going to start with, well, I was going to say I'll start with 5, but actually maybe I'll start with 100. Might be easier. So this is going to be 15 and 100, right? It's pretty easy to multiply things by 100, right? You just add 2 zeros on the end. 15 is 3 times 5, and 100 is 5 times 20. Okay, so we have 3 primes here already. We're going to circle those. And then 20, what's 20? That's 4 times 5. Have we finished? Almost. 4 is 2 times 2, and then we're done, right? So we need to circle the primes. So 1500, we can write, and I'm running out of room here. Let's move it over a little bit. 1500, we can write as 2 times 2 times 3 times 5. I'm going to do something a bit fancy here. I have 3 5s, 5 times 5 times 5. We can also write that as 5 cubed. That's another way of writing repeated multiplication. Okay, so that is how we're finding prime factors of numbers using factor trees and writing numbers as a product of prime factors. Again, really useful when we're looking for things like highest common factors and lowest common multiples, which we'll look at in a future video. This is a really useful list to remember as well. List of primes up to 31, or, just maybe the first 10 primes will do, and that's really going to help you out as well. So, okay, hopefully that was useful. Thanks for watching. I'll see you in the next one. Bye for now.